Hello, 8th graders. All right, you should have this green packet in front of you. So this is lesson 2. I kind of put it together in a packet to make it a little easier. Also, today's Mr. Activus' birthday, so make sure you tell him happy birthday. All right, so this is the warm-up. We have 2 graphs that could represent a variety of different situations. So notice we just have numbers on the X and Y axis. We don't have any labels because we don't know what it represents, which is okay. So we want to find the slope of each line. So I went ahead and I kind of wrote it in here. And I want us to be careful because normally we'd count the boxes 1, 2, 3, 4, 5, 6, 7. But if you notice, if you follow it all the way over, it's going up in increments of 2. So 14 to 28, which is 14. Okay, and then here, it's also going up by 2. So if you follow it all the way down, we're going from 16 to 8, which is 8. So remember, slope is always y over x. So for the first one, 14 over 8, which think about what it simplifies to. We can divide them both by 2 to get 7 over 4. So there's the slope of that line. Now let's do the other one. So again, it's labeled on here, but I did this one for us. So yes, you're going up 2 boxes, but really if you look on here, really going up 70. So 70, and then again down here, if you look right here, they're increments of 10, so we're going to the right 40. You can divide these both by what number? Yes, 10, which is 7 over 4. Okay. Let's read B. Andre claims that the line in the graph on the left has a greater slope because it's steeper. Do you agree? Well, yes, I agree that this line is steeper, but does it mean it has a greater slope? No, our slopes are the same. And really, we can go into more detail and say it's because of how the X and Y axis are labeled that that line is steeper. So really you just got to focus and see how we simplified, and there was a much easier for us to see that they have the same slopes. All right, you can flip that over. All right. So question 2. 2 large tanks of water are filling with water. Tank A is not filled at a constant rate, and you can see that by the curve in the line. That means it's not constant. And the relationship between the volume of water and time is labeled. So X is time, Y is water, liters. Tank B filled at a constant rate of 0.5 liters per minute. The relationship, notice how we just have tank A on here. We're going to be drawing tank B. The relationship between its volume of water and time can be described by the equation V equals 1/2 T, where time in minutes and V is the total volume. Okay, so we want to graph this tank B. So notice it says our equation V equals 1/2 T. So if I look at time, if I have time be 1, so 1/2 times 1, 1/2 times the time. What's 1/2 times 1? So hopefully you're thinking that's 0.5. So that would be a point on the line. So I go to the right one, up 0.5, which is like in the middle of 0.4, 0.6. I'm going to put my first point at the origin because after 0 time has gone by, 0 time has gone by, there's nothing in the tank. All right, if I do it again, and maybe I'm just going to pick this point right here, 1.6. Thinking about what's half of 1.6, 0.8. So this would be another point. So, and I just noticed I wrote those points backwards. I am so sorry. So 1.6, 0.8, perfect. And we can connect those with a line. So that's tank B. Okay. We're going to graph this on graph 2 now. Okay, so remember, we're taking the time and we're cutting it in half. So after 40 minutes, so I'm right here, when x is 40, What's half of 40? 20. So 40, 20 is a point. And again, I'm going to put my 0, 0. Okay, if I want to use 80, what's half of 80? 40. So 80, 40. I'm going to do one more point. I'm going to do the 60. What's half of 60? 30. So 60, 30. Connecting, you can see it's very close to that line. That's tank B. Okay. So down here it says answer the following questions, and we're going to say which graph we use because they're representing the same two tanks. They're just, as you notice, the time in minutes right here, we have a lot more minutes, a lot bigger numbers here and smaller here. Same thing with the liters. So after 30 seconds, which tank has the most water? After 30 seconds. So thinking about 30 seconds, the time is in minutes. So 30 seconds is half a minute. So do you think we can use graph B for that? Hopefully we're thinking no. So we're going to use graph 1. 30 seconds is approximately here 0.5. So if I follow it up, do you see how tank A is a much higher line? So tank A has the most water. Okay, let's look at number 2. Approximately what times do both tanks have the same amount of water? Well, if you look at graph 1, I don't see anywhere where they cross besides 0. So let's check graph 2. If you see graph 2, they cross right here. So I'm going to use graph 2 to say, again, the question is what times? So if you look right here, I'm going to say approximately 60 minutes. Oops, sorry. 60 minutes. All right, the next one. Approximately what times do tanks contain 1 liter of water? Okay, so now we're looking over here, 1 liter of water. 1 liter of water. So if I look over here, 1 liter, well, this is 10, so it's somewhere over here, and it's kind of really hard for us to see. So I'm going to think graph A would be a little bit easier to use. Sorry, first graph. Okay, so 1 liter of water. Graph A, so 1 liter, I follow it over, follow it down. About 1 minute. If I go over here, this one's a little harder to see, but if we think about what we know, we were taking our minutes and dividing it by 2, right? Minutes and dividing it by 2. So we're thinking the liters are Y, so what would this number be? So hopefully you're thinking 2, because 2 divided by 2 would give us 1. So we take 2 minutes. Okay, now we're thinking about 20 liters. Well, if you're looking at 20 liters, which graph is easier to see 20? Well, this only goes up to 1.8. So hopefully we're thinking graph 2. So graph 2 is going to be helpful now. So 20 liters of water. I'm going to start with this one over here because it's a little easier for us to see. So tank B, when it had 20 liters of water. So that's right here, 20 liters of water. So I'm going to say tank B is probably about 40 minutes. That's the one we drew. If you look at tank A, it's like kind of just before the 40. So I'm going to approximate that, probably like 35 minutes. Excellent. If you have this completed and you've listened to me, I want you to put a star in this corner right here of your paper. Okay, at this point, you can stop the video and complete the next questions on your own. Turn in the packet when you're done. Have a wonderful weekend.